Okay, so when you think about what makes plants grow, your mind probably jumps straight to NPK, right? Nitrogen, phosphorus, potassium, they get all the headlines. But what about the unsung heroes? The elements working quietly behind the scenes, literally building our world from the ground up.
That's what we're digging into today. We're going beyond the usual suspects to uncover these hidden forces, the ones that provide the real stability, strength, and honestly, the very spark of life for a healthy planet.
And here they are, our stars for today: calcium, magnesium, and sulfur. Trust me, by the end of this, you'll see why calling them secondary nutrients just doesn't do them justice. They are absolutely essential. So let's start with their main job title. Think of them less like food and more like master builders, the silent architects who are shaping the very foundation that life on Earth stands on. And this quote from our source material, it just nails it. They're not just some random minerals in the dirt. They are the literal bridge connecting the geology of our planet to the health of our own bodies. It's all one big, interconnected system.
So where do these incredible architects even come from? Well, their story starts deep inside the Earth's crust, in a process that takes, just a few million years. It all kicks off with something called mineral weathering. It's pretty simple, really. Rainwater, which is naturally a tiny bit acidic, falls on rocks for centuries, slowly, patiently dissolving them. And as those rocks break down, they release these vital elements into the soil. It's a slow-motion miracle. And this is where it gets really amazing. You can see how that geological process connects directly to you and me. It goes from rock to soil to plant to the animal that eats the plant, and then, finally, to us. So a problem in the soil doesn't just stay in the soil. It travels right up the food chain and can end up on our dinner plates. Now let's zoom in on magnesium's star role for a second. We all learned about chlorophyll in school, right? It's what makes plants green, what powers photosynthesis. But have you ever looked at its chemical formula? Right there, at the very heart of this incredible, life-giving molecule, is one single atom of magnesium. Without it, no chlorophyll, no photosynthesis, no energy. Game over.
So we know where they come from, but what do these architects actually build once they're on the job site? Let's break down some of their most crucial tasks, starting with calcium and sulfur.
Calcium's main gig is being a structural engineer. Our source material calls it the cementing agent of the soil, and that is the perfect way to think about it. It provides the stability and strength for the very ground we walk on. And the magic behind this is a fancy word called flocculation. But here's all it means. Those positive calcium ions act like tiny little magnets. They grab onto all the negative bits of clay and organic matter and pull them together into nice, crumbly clumps. This creates a perfect soil structure with plenty of space for air and water to move around, which is exactly what plant roots need to breathe and grow. And calcium's job as a builder doesn't stop in the soil. Inside the plant, it forms something called calcium pectate, which is literally the glue that holds plant cells together. When a plant doesn't have enough, its cell walls can actually collapse. You've probably seen this yourself, that ugly blossom end rot on your tomatoes or tip burn on a head of cabbage. That's a structural failure, all because of a calcium shortage. All right, let's bring in our third architect, sulfur. So if calcium is the cement and the glue, think of sulfur as the specialist who builds all the machinery. Its job is to create proteins by forming essential amino acids like cystine and methionine. These are the absolute fundamental building blocks of all life. But here's the tricky thing with sulfur. Take a look at this. About 95% of all the sulfur in the soil is locked up inside organic matter. Plants can't get to it. They need microbes in the soil to break it down and convert it into sulfate, which is the only form they can absorb. So at any given moment, only about 5% is actually available. And that leads to a very modern and kind of ironic problem. See, back in the day, industrial pollution and acid rain actually gave farmers a free supply of sulfur from the atmosphere. Now, thanks to clean air regulations, which are, of course, a very good thing, that freebie is gone. And as you can see here, the amount of sulfur falling from the sky has plummeted. And the impact of this? It's huge. This number, 15 to 40%, that's the typical drop in crop yields for things like mustard, pulses, and rice, especially in places like South Asia. This isn't just a small dip. It's a massive threat to food security for millions of people. So, okay, we've laid out the problems. But the good news is, we have the solutions.
So let's talk about how we can actively manage these nutrients and start to heal the land. The most important thing to remember is that you have to use the right tool for the job. This table breaks it down perfectly. If your problem is that your soil is too acidic, meaning the pH is too low, you use lime. Lime neutralizes the acid and brings the pH back up. But if your problem is too much sodium, which destroys that crumbly soil structure we talked about, you need gypsum. Gypsum sends in calcium to kick the sodium out without changing the pH. Two totally different problems, two very specific solutions. All right, for our final section, let's zoom out and look at the big picture here. Because this isn't just about adding powders to the soil. It's about restoring a natural, beautiful, and continuous cycle. At the end of the day, calcium, magnesium, and sulfur are so much more than just crop nutrients. They are the bedrock of ecological resilience. When they're in balance, the entire ecosystem, from the tiniest microbes to the largest animals, is stronger and more stable. And the best part is, we can all help support this cycle. Using the right amendments when needed, returning nutrients to the soil with compost, planting cover crops to keep the microbes happy, all these things protect what our source material beautifully calls the Earth's living skin. Which brings us to our final question. We've pulled back the curtain on the incredible work of these invisible architects. The real challenge for all of us now is, how do we make sure our actions support their work so they can keep building a strong, stable, and resilient world for all the generations to come?